So in the last video that we did, we looked at certain angles, pi over 6, pi over 4, pi over 3, and right triangles that had those angles, and what the and hypotenuse 1, and what the corresponding sides were, and then from that got the coordinates in the first quadrant of what would happen if your angles, say, were pi over 6 or pi over 4 or pi over 3, and what the xy coordinates would correspond to on the unit circle for those angles. And you see those labeled here. Now the labeling here is not ideal because we're measuring these angles, and I have them written here, but that's only so that we could tell which point is connected to which angle. So we'll all assume that this is our bottom ray, and that this is, and the center, or the origin, is the point connecting the two rays, and then the other ray is coming out here, and that our angles are defined that way. And so we have these 3 points already listed from our previous analysis by drawing a triangle, dropping a perpendicular line down here, and then taking those right triangles and using the sides that we already have. And then of course we should know these points just as a given. And so the question is, alright, what about all these other points here? Now, what you might notice about these points is that there are variations of these 3 angles in the other quadrants. So like pi over 4 goes, if you add a quarter pi, it goes up to pi over 2. I add another quarter pi, it's 3 pi over 4, pi, 5 pi over 4, etc. So we can count all the pi over 4s. If I add by 6s, I go 0 pi over 6, 2 pi over 6, which is pi over 3, 3 pi over 6, which is pi over 2, and then 2 pi over 3, 5 pi, 6, etc. And so we have analogs of these angles in all of these other quadrants. And so what I alluded to briefly there, but I'm going to just say a little bit more about right now, is like if I take a look at this pi over 4, pi over 4 triangle here, and then I reflected it this way, that's a congruent triangle over here with the same height, and the base has the same length, it just now extends the other way, right? And so from that, what you get is that for 3 pi over 4, your x value is minus root 2 over 2, but your height is still root 2 over 2. And then the corresponding point down here is just a reflection this way, right? Where you have the same x value, but your y value switches signs. So this value here has minus root 2 over 2, root 2 over 2, or minus root 2 over 2. Everything's negative. And then in the fourth quadrant, the x values are positive, but your y values are negative because you're below the axis, right? And following this, we could get values for all of the other special angles. So for example, this point is just a reflection of this point, so we would get minus 1/2 root 3 over 2, and then down here we'd have minus 1/2 minus root 3 over 2, etc., etc. And so you don't have to, I'm not going to go through all of these, this is already kind of difficult to read. In the text, of course, there is a nice clean unit circle with all of the angles labeled that you can go look at, that has all of these points. And that's easy as a reference point, but what this video is meant to do is show how one gets there and how we connect what we did with the three, or really two, special triangles and the three special angles, and how that extends to the entire unit circle and not just points in the first quadrant. Alright, thank you very much. See you in the next video.